Hello everyone, this is Professor Robert Solis. Welcome to our next video lesson. Again, we're going to continue talking about the while statement. It is responsible for a looping structure, and the way that we're going to use it in this particular application is to solve for factorials. Now, some of you may be intimidated by looking at this complex mathematical formula here, but really it's not that bad. Check this out. If a user says, I would like to find out what 4 factorial is, all that means is what is 4 times 3 times 2 times 1? Well, in this case, if you multiply everything together, that's going to be 24. If a user says, I would like to find out what 3 factorial is, that means what is 3 times 2 times 1? Well, that's 6. What is 2 factorial? 2 times 1. What is 1 factorial? 1 times 1. Now, the one thing that you may not know about it, it doesn't seem very intuitive, but it is mathematically accurate that 0 factorial is in fact equal to 1. So for right now, just take it for granted that 0 factorial is equal to 1, and then whenever you are finding the factorial of a number, it is going to be that number times 1 less, times 1 less, times 1 less, keep on going until you get to the actual number 1, right? So in this case, 5 factorial is really equal to 5 times 4 times 3 times 2 times 1, and therefore the answer is 120. So you're going to create a program that calculates the factorial. And here are some of the different software requirements. So let's go ahead and create the graphical user interface. So I already have Visual Studio open, and I'm going to drag and drop a button, a label, and also a text box to the form. You'll notice I'm calling this VB18 project because that's what that is, Visual Basic 18. And let's go from here. So it looks like there's a label over here that says enter an integer colon. All right, so I'm going to take this label, move it to the upper left-hand corner, and say enter an integer for the text property. At this point, I'm going to move the text box next to the label. So let me move this button out of the way. I'll move the text box over here. There we go. And now we have a button that says calculate factorial. So let me move the button to the upper left-hand corner and increase the size. Actually, I think that's probably a little bit too close. There we go. That's better. And let's see, calculate factorial is what this thing is supposed to say. So for the text property, calculate factorial. There we go. All right, now we have a 3D label down here. So I'll just take this label, copy and paste it. Now for the properties, I'm going to have to take the auto size feature, turn that to false so that I can resize this thing. And let me place it about right here. Let me look at the handout. It looks like that's about right. The text is inevitably going to be, well, actually first let me change the border style since I'm right here. The border style is fixed 3D. The text alignment property is going to be middle center, which is this guy right here. So there we go. Enter an integer. Now the text is supposed to be initially blank, so let me get rid of that. I'll take the form, reduce it to about like this. And what else do we have? Okay, we have to take off the minimize and the maximize property for the form. So the minimize box, maximize box, I'll set that to false. It looks like the name, or the text property rather, for the form is factorials. So let me change this to factorials. All right, so let's start naming the different controls that we have on our form. So for the text box, this is supposed to be txt user num. So txt user num. For the button, it is btn create factorial. btn create factorial. For the label, lbl result. All right. Now that I've named all the different controls, let me fulfill this last requirement, which says to associate the enter key on the keyboard with the calculate factorial button on the form. So let me select the form. For the accept button, I'm going to have an association with the btn create factorial. So in other words, pressing the enter button on the keyboard, or the enter key on the keyboard, is the same thing as if I were to click this calculate factorial button. They both do the same thing. All right, so let me go ahead and double click the calculate factorial button, and let's go ahead and put down a declarations comment. And we're going to get the user input. We're going to calculate the factorial, and then we're going to display the results. That's pretty much the layout of our program. I hope that you're starting to see a pattern that this is a very common layout. Basically, you're dealing with declarations all the time. You're getting some sort of an input, either from the user or from a file, say for example. You're going to do some sort of a processing or calculation step, and then you're going to have some sort of an output, and in this case, it's displaying the results. All right, let me go back to the handout, and it looks like I have to create a user num variable. So dim user num as an integer. Dim, let me see what's the next one here, factorial as an integer. All right, I didn't put this down on the actual handout, but I'm thinking that I'm probably going to need a counter variable. And I'll set that equal to 1. Maybe I need to set that equal to 0. Let's see. It depends on how I'm going to proceed with this program. In terms of the factorial, I know that from the handout I mentioned that 0 factorial is equal to 1. So at the very least, if the user puts a 0, the factorial has to be 1. Then it grows from there. So for example, 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, so forth and so on. So at the very least, it's going to be equal to 1. So I'm going to go ahead and say that factorial is initially equal to 1. And then I'll change it if it's something other than 0 or 1. Because as you can see here, if it's 0, it's 1. Oops, sorry. If it's 0 factorial, the answer is 1. If it's 1 factorial, the answer is 1. And then anything else, the value changes. At that point, I'll change it if it's supposed to be something other than 1. Well, let's go ahead and get the user input. So the user num is going to equal to, first let me convert to an integer in 32, whatever's inside the text box. All right, so in other words, what I'm saying here is get the text from the text box, convert it to a whole number, and assign it to the variable user num. Well, now that I have that variable, I can go ahead and use a while statement to determine how many times I need to go through this. So here's what I'm thinking. Let me go back over here to the handout and explain it verbally. If I have the user enter 4, right? Because they want to find out what 4 factorial is. Notice that the first number we'll consider is 4, then we're going to go to 3, then we're going to go to 2, then we're going to go to 1. Well, if I put this into a looping structure, I'll say, okay, consider the number 4, then subtract 1 from the 4, and now say, what is 4 times 3? Then take the 3, subtract it by 1, and say, oh, what is 12 times 2? Then take the 2, subtract it by 1, here's 1, so what's 24 times 1? All right, and so I think that's how I'll approach it. By the way, I can go the other way as well. I could say take the number 1, increase it by 1 to 2, increase it by 1 to 3, increase it by 1 to 4. So a looping structure will help me increase by 1 for every iteration. All right, so what I'll do is this. I'll say while counter is less than or equal to user num. Okay, press enter. At first you may be wondering, well, how did I know that it's supposed to be less than or equal to, or if it's just supposed to be less than, or if it's just supposed to be equal to? What I'm thinking is this, and I'll have to make sure that this logic works out, but here's what I'm thinking. Notice that we are basically starting with the number 1, then we're going to 2, then we're going to 3, then we're going to 4. Well, in this case, if the user entered 4, notice that we include 4 as our final number to be multiplied by everything else. If the user entered the number 3, again, notice how you have the number 3 in terms of determining 3 times everything else. So I'm thinking we're going to need to include, as the counter goes from 1 to 2 to 3 to 4, as counter increases, my thinking is that we're probably going to have to make sure that this is at least, as I mentioned here, less than or equal to. We'll see. Let's see if this logic ends up working out. Okay, so what is the factorial? Well, the factorial is going to equal to the factorial times, and then in this case, whatever the user number, or I'm sorry, whatever the counter is. Well, the counter I set equal to 1, so say counter. So at first, factorial, as you see, is equal to 1. Counter is equal to 1. So 1 times 1 is 1, no big deal. Now let me take the value of counter and increment it. So counter is equal to counter plus 1. So at this point, Counter is going to be 2. So let's say that the user says, I want to find out what 3 factorial is. You know from the handout that 3 factorial is equal to 6, right? All right, so here's how this is going to work out. When we first run the program, counter is equal to 1. Is 1 less than 3, which is the user number? That's a true statement. 1 is in fact less than or equal to user number. So therefore, factorial, which is equal to 1 from up here, is 1, oh, I'm sorry, what is 1 times 1? That's going to be 1. So at first, the factorial is going to equal to 1. Counter now is going to be incremented. It currently is equal to 1. 1 plus 1 is 1, so therefore counter is equal to 2 at this point. Okay, we go back to the while statement and ask this question. Is 2 less than or equal to 3? That's a true statement. So therefore we go over here. Factorial currently is 1. What is 1 times 2? Right, because counter is 2. Well, that's going to be 2, so this changes to 2. Counter, which is currently equal to 2, is now going to be incremented by 1, so therefore this goes to 3. Right, so this goes to 3. What is 3? Is 3 less than or equal to 3? That's a true statement. So therefore, we go into the while loop, and we're going to take the value of factorial, which is currently equal to 2. We're going to multiply it times counter, which as you can see is equal to 3. 2 times 3 is 6. Okay, counter now, which is 3, we're going to add 1 to it, so now it's going to be 4. Go back over here. Is 4 less than or equal to the user number, which I said is 3? Is 4 less than or equal to 3? That's false. So we are finished with the while statement, and now we can output the results. So in other words, what I'm saying here is that LBL result.text is going to equal to the convert to string, whatever the value of factorial is. Let's see if this works out for different numbers. Like, for example, what if the user entered 0? Okay, let's say that the user has 0 in this text box, so therefore user number is equal to 0. All right, is counter, which is equal to 1, less than or equal to user number, which is 0? Is 1 less than 0? False. So from here, we would never even enter the while statement. We would go to here, and then we'd go to here. We would output the value of factorial. Well, what is the value of factorial? It's my initial statement over here where I initialized it to 1. And that is in fact correct because, as I mentioned to you before, the mathematical rule is that 0 factorial is in fact equal to 1. So 0 factorial equal to 1 seems to work. How about this? How about if the user entered the number 1? Okay, so now user number is equal to 1. Is 1 less than or equal to 1? Right? Because counter is equal to 1, as you can see up here at first. Is 1 less than or equal to 1? That's what the user entered. That's a true statement. Okay, well, since that's a true statement, let me get rid of these comments. Factorial, which is 1, times counter, which is 1. 1 times 1 is 1, so factorial would be 1. 1 plus 2 is now 2, so counter is now 2. Is 2 less than or equal to 1? That's a false statement. So we would jump out of the while statement. We would then output the result of factorial, and factorial is 1 in this case. So therefore, 1 factorial is equal to 1. So at least from my quick preview, it looks like everything is going to work, but now let's actually execute the code to determine if this is in fact correct. So let me run it and type in 0. 0 factorial is equal to 1. Good. How about 1 factorial? That's 1. 2 factorial is 2 times 1. That's good. 3 factorial is 3 times 2 times 1. That's good. 4 factorial is 4 times 3 times 2 times 1, which is 24. Good. 5 factorial is 5 times 4 times 3 times 2 times 1. So when I click this, it should be 120. Good. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. So in this case, that should be, let's see here, 600 plus 100, no, 720. Okay, good. So it looks like the factorial program works. Now what I want to do is go step by step through this program to make sure that you understand how this logical part of the program works. So let me stop the code right here where we're going to get the user input. And I'll go ahead and click Start Debugging. So let's go through this 3 times. Now 3 times 2 times 1 is 6. Okay, so 3 factorial should be 6. Let's see what happens step by step. So I'm going to click Calculate Factorial. Well, the first thing we're going to do is we're going to stop at this statement and notice that we're going to get the value within the text box, which is 3. 3 is going to be converted to an integer, and it's going to be assigned to the user number, which in this case should be 3. So let me step over, and sure enough, here's user number is now equal to 3. All right, so now we are asking if whether or not we should go into this while statement. So is 1 less than or equal to the user number, which is 3? Remember, I initially started off with a counter value equal to 1 up here. I set it equal to 1. 1 is, in fact, less than or equal to user number. That's a true statement. So therefore, let's step through this, and sure enough, it goes into the while block. Factorial, I initially set equal to 1 from up here. So that's why you'll see that factorial is currently equal to 1. Counter is equal to 1. Therefore, 1 times 1 is equal to 1, so when I step over, factorial should be still equal to 1, and sure enough, there it is, factorial equal to 1. All right, at this point, counter is equal to 1. 1 plus 1 is equal to 2, so therefore counter should be equal to 2 after I step over this. Sure enough, when I do that, counter is equal to 2. All right, let's go back to the while statement and determine if whether or not this is in fact still true. Well, is 2 less than or equal to 3? That's a true statement, so therefore when I click step over, it goes into the while statement. All right, factorial is equal to 1. Counter is equal to 2. 2 times 1 is 2, so therefore factorial will be 2 when I click this step over button, and sure enough, here it is, factorial is equal to 2. Let's increment counter now. It's currently 2. When I click this button, it'll be 3 because 2 plus 1 is 3, so counter is now equal to 3, as you can see over here in the auto section as well. All right, so let me step through this and ask the question, is 3 less than or equal to user number? Yep, 3 is less than or equal to 3. That's a true statement. So we're going to go into the while loop. Notice that factorial is equal to 2. 2 times 3 is equal to 6. So therefore factorial is going to go to 6. And then counter is going to go to 4. So factorial is equal to 6. Counter is equal to 4. Remember, we're asking what is 3 factorial? Well, 3 factorial is 1 times 2 times 3, which is 6. So now when I go back over here, what is counter? 4. What is user number? 3. Is 4 less than or equal to 3? No, it's not. So therefore, when I click step over, it'll jump out of that, and we are now ready to display the results of factorial into the text property of the label. So I click this, and in fact, let me just go ahead and click continue so that we can see the results, and there it is. Okay. So the idea is this. I'm trying to use, let's go back over here to the handout. I'm trying to use or to observe patterns. And if you'll notice that there is a pattern where it increases from 1 to 2 to 3 to 4 for 4 factorial. If this were 10 factorial, it would be 1 to 2 to 3 to 4 to 5 to 6 to 7, 8, 9, 10. Right? So when you see patterns like that where numbers are increasing, like they're increasing by 1 or by 2 or whatever, there seems to be a series in terms of increasing or decreasing. The first thing that you should think of in terms of how to create your program is a while statement or some sort of a looping structure, because that's how you'll be able to go from one number to the next number. So that's why my first thought was, okay, I'll start off with the number 1. Then I'll multiply 1 times 2. That's 2. Then I'll multiply 2 times 3. That's going to be 6. And then I'll take 6 times 4. That's going to be 24. Right? So I'm doing the exact same thing in terms of this mathematical formula, but I'm using a looping structure to find out what that answer is in fact going to be. So as you can see here, this is not a large program, but the thinking that is required is a little bit more intensive, right? So you're going to have to make sure to understand this. Go through the video lesson another time if you have to. The textbook also does a great job of describing how while structures work, or how the while statement works, specifically looping structures. All right, I think that's it. So this is Professor Robert Solis. I hope this is helpful. Have a good day, and see you next time.